Yeah, so welcome back everyone. So today I will be speaking to you about Azure Kubernetes new feature called AKS Automatic. I'm Ahmed, I'm a Microsoft Azure MVP, and I'm a cloud consultant at CCL Spark. So in the in Microsoft build, so Microsoft introduced a new feature. So for just to take it a step back, the AKS is a managed Kubernetes service, right? So like instead of you having to maintain a lot of the underlying infrastructure for Kubernetes, what Azure Kubernetes Service is, it takes care of a lot of the infrastructure, but it exposes you to the, gives you all the power to connect to the Kubernetes API, install add-ons, and then manually configure a lot of the feature. So basically, it is the powerhouse of Kubernetes. And all the cloud providers, of course, provide managed Kubernetes services. And there was a recent CNCF Cloud Native Foundation state of Cloud Native. And I think it is 75 plus people who are using Kubernetes actually use managed services. So what Microsoft announced in the recent build is a new SKU. It's called AKS Automatic. And what that basically is, it's an evolution of the current Azure Kubernetes Service, as in that when you install Azure Kubernetes Service, you get the basic managed service without any add-ons, without any configuration, without any default setup, right? The assumption is that you have to do that yourself. And what happened is that a lot of clients, a lot of customers come back to Microsoft asking about questions like, how do I make sure that my Kubernetes service is secure? How do I make sure that I'm getting the best out of it? And then how do I get it set up out of the box, right? So based on hundreds of thousands and tens of thousands of customers and then all the experience, Microsoft decided to build a new SKU, and they called it AKS Automatic. And it is from what the name sounds. The idea is that it gives you default configuration in 4 pillars, which is the security, the networking, the auto-scaling, and of course, observability, right? So these are the default configuration, or like the best default configuration for most users. So in each and different pillar, you get default and then even add-ons configured out of the box, so that you could use your Azure Kubernetes service almost from day one, right? So I'll explain a little bit about what are the add-ons and what are the default configuration for AKS Automatic. And I'll talk a little bit later about the use cases and what makes sense to actually use AKS. So the first thing is, of course, is that the security. So the AKS Automatic comes already with using Azure Linux. So it is a secure hardened Linux that Microsoft Azure provide. And it also comes with things like automatic upgrades. And with automatic upgrades, what I mean by that, so when you spin up an AKS cluster, you've got nodes that are forming your cluster, right? So like these nodes basically are virtual machines that you spin and then you provision your pods and containers on top of, right? These nodes need upgrading, right? So like you need to keep on upgrading these nodes, security patching these nodes. And this is something that operation team normally do using the AKS standard, right? What Microsoft is doing now, if you use the automatic SKU, you get that you will always be updated to the latest image, to the latest security patch. Automatically, you don't have to do any manual intervention. So your AKS cluster nodes are always up to date, right? The other thing is that to make it even more secure, it gets enabled, it comes in with RBAC already enabled. And what RBAC is, of course, is role-based access control. So based on each person each user or like admin in your organization, they get a a specific set of access credentials. So like you are allowed to access this resource, you are not, based on the RBAC role. So this gets default configured for you. With the AKS standard, you have to do that yourself. With the automatic, it's already configured. You just need to, people with the assigned roles could just easily access the cluster. It also comes with to even more hardened so that it will disable local admin access to the nodes and the SSH access. So you will only be able to access your cluster using the API. So no access to the cluster or nodes within the cluster using SSH or local admin. The other thing, which is the workload identity. So before, like in an AKS cluster, you would use a service principal, which is basically how you give your resources, like a node or a virtual machine. Oh, sorry.
Keep going. I think that's just noise from our mind.
All right. Yeah. So what that basically means is that you would have to provision your nodes with access to resources within Azure, and that historically means that you'd have to give each machine a secret, and then you have to keep that secret in a key vault, and then of course you have to rotate those secrets. And then if the secret is leaked, people would have access to your cluster. If it is outdated, it's a manual task that you have to rotate those secrets. With the workload identity, you basically just give the workload an identity, and it just authenticates with Azure. So as long as the workload has this identity, no secrets involved, it would automatically be able to access resources that you allow it to, right? And it's actually even a movement apparently to actually use workload identity as a more secure way of giving your resources access to Azure. The other thing, which is the image cleaner, what that means is that, you know, when you install a container image, and then later on there's a new container image with like a much more secure one, much more trusted. What happens with the day-to-day operations is that sometimes you forget those container images within your cluster, and the container cleaner makes sure that if this image is no longer used, and if it is unsafe, it would automatically remove it. And of course, network resource lockdown, which basically comes with all set of network security rules to lock down your cluster and isolate it so that it would only be allowed to talk to resources on the internet that you allow it to. And especially if you have a cluster with multiple tenants, and then you don't want these tenants to talk to each other. So let's say that you are providing services to multiple clients, and these clients are sitting on this cluster. You don't want them to access each other. So this comes, if you are using the Azure Kubernetes Service standard, you would have to manually configure this. The automatic one comes in already configured so that multi-tenants are isolated. And of course, it comes with key vault provider add-on. It comes with policy add-on, all sort of configurations. So like limitation on resources. So you don't want to have one of your pods to be using more resources than allowed, and then like overutilizing your cluster resources. And of course, safe deployment, making sure that only trusted containers and only safe images are being used in your deployment. And for networking, there are three main categories that comes again configured by default. You've got the container network interface, you've got the application routing, and of course the NAT gateway. So what a container network interface is that Kubernetes by default does not provide you with networking, right? So the Kubernetes specification is only responsible for making sure that you orchestrate the containers and your containers deployment. What Kubernetes does, or what I should say the Cloud Native Foundation does, is that they've got something called the CNI specification, Container Network Interface. So it's a specification that if you want to develop your own container network to provide networking within the cluster, you should follow this specification. And there are a lot of CNIs in the landscape of CNCF. One of them is Cilium. So Cilium is a it's a very popular CNI. It's been used a lot recently. A lot of so Microsoft, AWS, and GCP are all now leaning into using Cilium as the default CNI. So what the AKS Automatic does is that by default you come with Cilium configured, and with any manual or standard, I should say, AKS, you would have to pick your CNI when you do that. And for the app routing, what that means is that, again, so like if you've got services, like you deploy an application on Kubernetes, and then you want to expose these services to the internet. So that means DNS, that means you have to configure the routing to multiple services within your application. AKS standard would have to ask, you would have to do that manually. You would have to provision the application and make sure you have the DNS entries, make sure people can access it. AKS Automatic comes with that configured already. So it gives people access to your services. It takes care of the DNS configuration. And of course, for egress, when you want to send traffic from your cluster to the internet, normally resources within your cluster are using what is called private IP addresses. Private IP addresses means IP addresses that allow you to connect to resources within your local network, but you cannot use these IP addresses to connect to the internet. You would need to use what is called a public IP address. So a public IP address is it's an expensive resource. You have to buy it from from an organization provide you with IP addresses, and then what you need to do if you want to access the internet is that you want to translate the private IP address you use into a public IP, which is called the process of NATing. So a NAT gateway allows you to do that. It automatically allows you to access the internet in a secure way. And then again, that comes within the AKS Automatic. The other domain, which is the autoscaling. So there are three vectors that you could autoscale your cluster. So you've got the number of the nodes. So for example, if you've got a small application, you might spin up one node. And a node, again, is just a virtual machine, right? But what happens if the demand on your application increase? You either manually go and then increase the number of nodes, and that's not good because your users will suffer of low resources if you've got only one node. So what Microsoft is doing with the AKS Automatic is using something called Karpenter. It's an open source CNCF tool that actually automatically, based on the demand. So if the demand increase, it would provision more virtual machine, more nodes. If the demand decreases, it will start to deprovision those nodes. And that comes in configured with AKS Automatic from the get-go. And then the other thing, which is called KEDA, which is, I think, Kubernetes Elastic.
Event-driven autoscaler.
Yeah, event-driven autoscaler, exactly. Yeah, so what KEDA is doing, it's another open source. It actually started from within the CTO office, Mark Razanovich. It's an open source CNCF tool. It's a graduated project. It's really awesome. What actually it does, so then normally Kubernetes is just looking for resources like CPU and memory, right? And what KEDA is doing is looking a lot more metrics, so like the number of HTTP calls, like if there is a message in a service bus, and so on and so forth. Based on a lot more metrics, it's looking and waiting for all these. And if it sees that the current number of pods within your cluster is not enough, it would increase the number of pods. This is called horizontal scaling. What horizontal scaling means is that basically replicating more and more nodes. So like you've got one node, you increase the demand, one pod, I should say. So you increase more and more pods. The vertical pod autoscaler, the VPA, what that means is that this is different. So the horizontal is that just basically replicates more and more pods and more containers. The vertical one is actually gives more resources to your pod, so like that CPU and memory. So when the demand increase, it would increase the resources available to a pod. And again, all that in a standard AKS, you would have to configure yourself. And then finally, of course, with observability, you've got Prometheus to look for all the metrics. You've got Grafana to give you access to graphs and dashboard to understand those metrics. you've got container inside, you've got Azure Action Group, all sort of observability monitoring built into AKS from Automatic from the get-go. So to answer the question is like, what do we do now? What is the difference between the AKS Automatic and the AKS Standard? Where should I use each? And there's also something called Azure Container Instance, Azure Container App. So the Azure Container App is another service by Microsoft, allows you to deploy your containers on top of Kubernetes, but you get no access at all whatsoever to Kubernetes. Everything is hidden. It is all managed by Microsoft, right? The Azure Kubernetes Standard Service, on the other side, gives you the full access to the APIs, takes care of some of the infrastructure for you, but you get much more access to the API. The AKS Automatic actually sits in the middle. So the idea is that it is still the power of Azure Kubernetes Service. It is giving you access to the APIs, but what it does, it just takes the manual work from you. So you get all of the configuration, all of the add-on from day one. And there is no difference in complexity. So like, it doesn't matter if you are saying like, oh, for more complex scenario, maybe I should use the manual one. Unless you don't want to use what comes into the automatic, like you don't want to use the Cilium CNI, you don't want to use, for example, managed Grafana or whatever, managed Prometheus, that's when you'd say like, okay, the automatic is not going to fit my use case. And yeah, that's about it. So thank you guys.
Wow.